Let's have a look at the components of a brushless alternator. This is the stator body, and this is the rotor assembly. The stator body houses a main stator and the exciter stator. Similarly, the rotor assembly consists of a main rotor and the exciter rotor, along with a bridge rectifier assembly mounted on a plate attached to the rotor. The exciter stator has residual magnetism present in it. When the rotor starts rotating, AC output is generated in the exciter rotor coils. And this output is passed through a bridge rectifier and is converted to DC and given to the main rotor. The moving main rotor generates AC current in the stationary main stator coils. This is the final output of the alternator. The exciter plays a key role in controlling the output of the alternator. It supplies DC magnetizing current to the rotor, which is the field of the main alternator. Thus, if we increase or decrease the amount of current to the stationary exciter field coils, the output of the main alternator can be varied. Automatic voltage regulator circuit performs this important operation of controlling the exciter current. Let's have a look at the working of the AVR. For example, let's assume the output voltage is low. The AVR senses this and increases excitation current in the exciter stator. This in turn increases the output from the exciter rotor. This increased output is converted to DC and fed to the main rotor, thus increasing its magnetic field strength, resulting in increase in the output. Similarly, when the output voltage is high, the AVR will decrease the excitation current, resulting in controlling the output. The result of all this is that a small current in the exciter field helps in controlling the output of the alternator. Important. Test procedures shown in this video assume that the viewer is well conversant with electrical safety requirements and has the knowledge of using electrical test equipment. Never attempt to work on live equipment if you are not qualified or experienced in this work. While testing a live generator, another competent person must be present who can shut down the engine in case of emergency. Stop the generator and disconnect all load. Battery test. Remove AVR connections. Insulate the U, V and N terminals with tape. Replace the AVR with a 12-volt battery. Give battery positive to F1 and negative to F2. Now start engine. Check that the speed is within 4% of the nominal. Using a multimeter, check voltage between phases and voltage between each phase to neutral. If the output voltage is within 10% of the nominal and balanced across phases within 1%, then main stator, main rotor, exciter stator, exciter rotor and rotating rectifier assembly are functioning correctly. If the output is more than 10% below the nominal and also unbalanced across phases more than 1%, this indicates that a fault exists in the main stator, main rotor, exciter stator, exciter rotor or in the rectifier diodes. Checking the main stator winding. If the phase-to-phase voltage is unbalanced by more than 1%, this indicates that the main stator windings are faulty. Unbalanced voltage, heat or burning smell from the windings. Engine sounds like loaded or no load. These are few symptoms of main stator fault. Disconnect the AVR. Disconnect any connection between neutral to earth. Measure the insulation of the windings with a measure. Value should be higher than 1 mega ohm. If the value is lower than 1 mega ohm to earth, the windings should be cleaned, dried or removed to a workshop for complete refurbish. If the voltage is 10% or more below the nominal voltage, but is balanced within 1% phase to phase, then the main stator is in good condition. If the main stator is good, then RRA, rotating rectifier assembly, main rotor, exciter stator and exciter rotor must be checked. Testing the rotating rectifier assembly diodes. Disconnect one lead of the main rotor connections from the rectifier assembly. Disconnect the 6 ends of exciter rotor connections to the rectifier diodes. You have negative base diodes and positive base diodes. The rectifier assembly is split into 2 plates. Each plate carries 3 diodes. The negative plate carries the negative base diodes and the positive plate carries the positive based diodes. Switch the multimeter to the position indicating diode test position. Put the positive test lead on the anode side of the diode. The meter should give a reading indicating electron flow. Reverse the multimeter leads. The multimeter should now read OL, no electron flow. A faulty diode will give a short circuit reading in both directions or an open circuit reading in both directions, usually because of solder joint fail. Care must be taken to ensure that the correct polarity of diodes are fitted to each respective plate. When fitting the diodes to the plate, they must be tight enough to ensure a good mechanical electrical contact, but should never be over tightened. Please note, if one or more diodes are found to be faulty, always change the complete set of diodes. Exciter stator. Check the resistance across F1 and F2 with a multimeter. Set the lowest resistance range for this test. Also check the insulation of the exciter stator with a mega. The minimum insulation value should be 1 mega ohm to earth. Exciter rotor. A visual inspection will usually identify any burnt or damaged winding. A low resistance bridge is required to accurately measure exciter rotor resistance values, usually below 0.5 ohms. Main rotor. Disconnect one lead of the main rotor connections from the rectifier assembly. Check the resistance of the windings with a multimeter. A good quality multimeter will measure resistance of 0.5 to 2 ohms with reasonable accuracy. However, if the resistance is found to be lower than quoted figure, it should be verified with a more accurate measurement. Field flashing. Self-exciting alternators use residual magnetism of the magnetic circuit of the exciter. Loss of residual may occur after a breakdown, long shelf time, or rewind of the exciter stator. Connect a 12-volt DC battery positive to AVR terminal F1 and negative to terminal F2 for 1 second. Caution! Never connect a battery to the AVR terminals without a blocking diode. Battery polarity must be correct.